So one of the challenges of learning calculus is that you have to know a lot of math before you learn calculus. For example, if you wanted to use a book like this one to learn calculus, this is College Calculus with Analytic Geometry by Prater and Mori. You would have to know college algebra, so you have to know some algebra. You have to know trigonometry, so you have to know the trig functions, what they are. And typically you have to take a course on pre-calculus as well. So you need a lot of math. However, in this video, I'm going to show you how you can actually skip using books like this one and use an easier book and actually learn calculus on your own through self-study. That's right. So I have the book here, and this is actually a book that I have used to teach in college, a course specifically designed for students who don't know trig, because this book does not assume that you know any trigonometry, right? Which is absolutely amazing. And you might say, well, isn't it better to know trig and know calculus? Yes, it is. Absolutely. It's definitely worth knowing trig. But if you don't know trig and you want to learn calculus right now, all you need is some basic algebra. And this book here, it's called Brief Applied Calculus. This is the 5th edition, and it was written by Beersford and Rocket. This book is kind of hard to find. I think it's kind of expensive. I'll leave any links to any copies I can find on the internet in the description of this video. And the reason it's kind of hard to find is because this is a course, and this type of book isn't very popular, okay? So who takes this, right? So if you go to college and you're like a business major sometimes you have to take calculus maybe, depending on what you're doing. Sometimes it's called business calculus at certain schools. This actually has business applications that you don't find in more hardcore books like this. And it's got some interesting, tricky stuff that you don't see in books like this. So, although this has way more stuff in it. I mean, look how thick this is, right? Compared to this little book here. 1,000 times easier though. So you can get a book like this, and then you just basically, what you want to do, we're going to look at this book in a minute, but what you want to do when you get a book like this is just devote a time every day to work on it, right? Like spend 30 minutes a day working on math. And my advice is do it in the morning, right? Because if you do it in the day or you do it at night, it's going to take time away from something else. You have to create more time in your day by waking up extra early and doing it. I know it sounds hardcore, but it's a really good way to do it. Get up extra early and do mathematics. That's my advice. Brief Applied Calculus. Oh, I love this book. This book is so good. Before we talk about the contents, let me just say that this book is so good that I have taken ideas of certain things that I have seen and explanations in this book and actually used them when I've taught Calc 1, Calc 2, Calc 3, Honors Calc, all that stuff, because it has that good of the explanations. Like it's that well done. Anyways, let's take a look at the content. I think I missed it. It's back here at the beginning. So there we are. And the contents are, here we go. It says functions, derivatives and their uses, further applications of derivatives. So all this stuff here is Calc 1 stuff. So this is all Calc 1 stuff right here. Really basic. Yeah, this is new. So this is something you wouldn't see in a regular Calc 1 class. Optimization, a little bit, it's pretty hard too. And then this is even harder. 3.4 and 3.5, that's way harder. That you don't see in a Calc 1 class. So if you've had Calc 1, you've never seen that. So even if you know calculus, you're still getting some new content in this book. And then implicit differentiation and related rates, you do see that in Calc 1. The related rates problems in this book are very easy compared to the ones in like a modern book, like I have one here, like Thomas Calculus. You know, a book like Thomas Calculus will have harder problems than this book in the related rate sections, just for comparison, since I have it here. This is a really easy chapter, super easy. Like, you know, the questions are like, compute e to the second power, like very simple. Wait till you see the exercises in this book and you'll be like, whoa. Here we have some integration stuff. A lot of business applications here, as you see. Consumer surplus and income distribution. And then this is Calc 2 stuff, actually, right? So you've got some Calc 2 topics now. That's kind of fun. And then over here, you've got some Calc 3 topics. So the authors have thrown in Calc 1, Calc 2, and Calc 3 topics. So to me, that's very exciting, you know? That's another reason I love this book. It's a book that's easy to read. You can use it for self-study. It's got a little bit of Calc 2. It's got a little bit of Calc. It's like the easy stuff in Calc 3. This is not hard. Well, I mean, yeah, it's pretty simple. Let's go there. Let's go to the Calc 3 stuff. Let's just go there right now. So you can see, let's look at the treatment, because Calc 3, you know, the treatment in like the book by Stewart is pretty hardcore. So let's look here. This section discusses integration of functions of several variables. We define the double integral of a function by considering the volume under a surface. Okay. And look at this beautiful picture. So here's your surface, z equals f of x, y. And you're looking at the volume under f above the rectangular region R. Let's see. And then you begin by approximating the volume by rectangular solids, boxes, extending from R up to the surface. Isn't that a great picture? Here's the little rectangular solid of length delta x and width delta y and height f of x, y. Right? Because that's the height, because that's the surface. So the surface determines the height. And therefore having the volume equal to that product. You see that? Cool, right? And then if we come over here, look at this beautiful explanation. And hopefully you're still with me. If not, it's okay. Rewind the video, watch it again. This is beautiful. Or you can get this book. It's really good. The volume of the rectangular solid is this, right? The sum of the volumes approximates the volume. Right? It's an approximation. So the limit of this sum is both delta x and delta y approach 0, so that the base rectangles become smaller and more numerous. I love how it says that, right? Because what's happening is, let me go back to the picture. So pretend you have like infinitely many of these. So when delta x and delta y go to 0, this gets skinnier, right? But remember, you have a sum, right? So your sum is an approximation. So maybe your sum, let's just say it has 30 rectangles, right? Well, now it's a variable. Let's say it's n. So as the number of rectangles grows, right, what happens is that delta x and delta y, well, they also get skinnier. So both things happen, right? And then here you have this limit. The double integral of a continuous function, f of x, y, in a rectangular region R is, so there it is there. The sum is over all rectangles in R, each containing one x sub I. I think that's a great explanation. I think this is a great book. In other books, it's way more, like, it's just very clean. Look at this. Look at all this. Look at all this. This is gold. I got to smell it. The chapter on, let me show you the chapter on continuity, because that's a really good one. There's some stuff there that's really good. I like the examples. I like the boxes. You see how they're yellow? I don't know. Even the layout is nice. This is probably, I hate to say this might be one of my favorite calculus books. Or my favorite. It's just really that good. It is lacking though, right? It doesn't have any trig. Doesn't have any trig. So here they define it this way, you know, as in 3 pieces, right? You don't have to do that. You can just say it's continuous if condition 3 holds, right? Because condition 3 implies condition 1 and 2. But the reason they do this is because they give you all the different cases, and they talk about all the different reasons. And they have questions in here where they ask things like, you know, is it continuous? If not, you know, give the reason it fails. They have online homework for this book, and in the online homework they have questions like that. Sometimes I've seen that. So it's really nice. It gets people to really think about, you know, what the definition is and why it fails. The actual exercises, so like, let's go to so like this is like higher order derivatives. These are really easy. That's marker. It's me, my marker hands. And let's go to like, here we go, product and quotient rules, so you can see. And keep in mind, you know, people who take this class, like, you might say, oh, this is really easy, but they haven't had trig or pre-calc, so they've had a lot less math than a person who takes Calc 1. So that's something to keep in mind. That's why it's like this. It's very repetitive, right? But that's how you learn. And people struggle with this. Like, it's, you know, again, from teaching this and teaching Calc 1 and Honors Calc 1, like the difference is large. Because after you have, you know, trig and pre-calc, like if you survive those classes, like even if you just do okay, you're going to be a lot better than you are now. And that's very apparent because you can see how much math people know coming into this class versus a Calc 1. So it's nice because you see the whole section is just that. So it's a very fun class to teach because you can spend an hour just doing examples, right? It's just really fun. You know, that's why it's one of my favorite classes to teach because of that. Even though you don't get to do trig and stuff, and you still get the really hard applications. Yeah, this is tough. Further applications of optimization. This is the worst right here. Optimizing lot size and harvest size. I make it extra credit when I cover it. I don't require it. It's just too much. It's too much. You know, people already struggle with like implicit differentiation, chain rule. I mean, again, this is, if you know algebra, you could do this. Yeah. I will look, and if I can find any links, I'll leave a link in the description to this book. If I can find any copies. If you want to learn math, I do actually have calculus courses. They're on Udemy. If you get them, please use the links in the description of this video or from my website, mathsorcerer.com. Anyways, keep doing math.